All right, 1.5 is solving one variable inequalities. You're going to solve them, and you should have done these last year as well, but solving inequalities, you're going to solve them just like a normal equation. So you're going to minus 3 on both sides, and then you're going to get 2x is less than or equal to 6. Divide both sides by 2. X is less than or equal to 3. Now, again, as far as graphing it, what you're going to do is you draw your number line. The way I want number lines drawn is, first of all, put arrows. Number lines have arrows. Lines have arrows. And then put 0 in the middle. And then my only other requirement, I guess, is to put the left side of the 0. I mean, on the left side of the line is the same as the other side. So if you want to put 1, 2, 3, then you got to put -1, -2, -3. Whatever you count by, I don't care what you count by. You can count by 2, 4, 6, or whatever. But whatever you put on the right side of that line, I want you to put on the left side of 0 as well. All right, and then this says all the numbers less than or equal to 3. So less than or equal to 3, you're going to put, here's 3, less than or equal to. So it could include 3. So it's a closed circle, a filled-in circle, and less than is all the way to the left. Less than is to the left. Greater than is to the right. All right, and then again, one little hint is the arrowhead will match the arrowhead if the variable is on the left side. All right, if the variable is on the left side, the arrowheads will match. To better do that. All right, this next problem, again, you solve it like a normal equation, and then what we're going to do is graph it. So we're going to use the distributive property. So that's going to be negative 12x plus 4. Combine like terms, the x's are like terms, so we're going to get negative 6x minus 4 from both sides. And we're going to divide both sides by negative 6. Now, again, you should remember this from last year, but even if you don't, there's like a little special rule you got to know. Whenever you're dividing or multiplying by a negative, it switches the direction of the inequality. Again, when you're multiplying or dividing by a negative, again, notice just because I'm subtracting 4 doesn't mean I switch it, but whenever you're multiplying or dividing by a negative, then you switch the direction of the inequality. So this says x is less than negative 2, but by the way, you always pronounce the x first, so x is less than negative 2, and so you have a number line, 0 in the middle. Remember, put arrows, put 0 in the middle, and then less than negative 2. So here's 1, here's 2, here's negative 1, here's negative 2, and less than, here's negative 2, but we're going to leave an open circle because less than negative 2, it means it does not include negative 2, but it's less than, so it's going to be going to the left. Again, less than is to the left. And again, as long as the variable is on the left side, which it is, then the arrowheads match. The arrowheads match. Less than is to the left. All right, let's go to another problem. This one has decimals. And again, you could keep it as a decimal if you don't want to. In class, I showed you guys how to get rid of them. On a decimal equation, you could just simply look at the biggest amount of decimals and move everything over 2 decimal places if you want. So, either way is fine. I'm just going to move everything over the decimal places. Again, you don't want to. If you don't want to, just keep the decimals the way it is. But the biggest amount of decimal places is right here, 2. So I'm going to move everything over 2 decimal places. So that becomes 230x. Move this decimal over 2 places, so that becomes 1900. Move this over, it becomes 15x. And move this over 2 places, it becomes 240. And again, you don't have to do that. You can leave it as a decimal if you want. So I'm going to minus 15x and add 1900 to both sides. Remember, what you do to one side, you have to do to the other. So on the left side, you have 215x, and on the right side, you're going to get 2,140. And then you're going to divide both sides by 215, and then this goes to 428. over 43. So remember, you can write a reduced fraction. Don't round. I've said that several times in class as well. Don't ever round your decimals unless you're instructed to. By the way, this approximately equals 9.95. Again, approximately equals 95, and we'll need to know that for the number line. But again, as far as your answer, I always want the specific answer, like the very precise answer, a reduced fraction. I don't want a rounded decimal, again, unless the instructions tell you to. So as far as drawing the number line, again, 0 in the middle. And again, I know that's approximately close to 10. So if I wanted to, count by 5 and then 10, -5, -10, if I wanted to do that, and it's less than or equal to, so it's a little bit less than 10. So it's about right here, a little bit less than 10, and it's less than or equal to. So again, a closed circle, less than or equal to. Less than or equal to is closed, and less than is to the left. Greater than is to the right, less than is to the left. All right, so this problem right here, we have two more problems. So if I start to solve this, and like if I add 6x to both sides, what I'm going to end up getting is there are no x's left, and you're left with this. Now ask yourself, is that true? Is 15 greater than 9? Well, yes, it is. So, and you're like, well, is that my answer? Well, remember, I'm always trying to solve for the x. In this case, I want to know what x is. So, you ask yourself, well, there is no x. The x is crossed out. Yes, but remember what I started with, okay? And I want to know what x is in this case. So, if the x is ever crossed out and you're left with a true statement, then the answer is all solutions. It's literally every single x will work. Like literally, if you put -6 blank plus 15, -6 blank plus 9, and if you plug in, pick some random number like 2, some random, I don't care what number it is, but pick the same number. And so -12 plus 15, that's 3. -12 plus 9. And you're going to get 3 is greater than -3, which is true. So 2 works. But again, you can plug in 3 and it will work. Plug in -15, it will work. Plug in -400 million, it will work. So all solutions will actually work. Now, how do we actually graph that on a number line? So, how do you graph every single number on a number line? Well, again, if this was 0, and so there's 2 ways to do this. You could simply just darken the entire number line. And that's one way to do it. Another way to do this is you could put a closed circle at 0 and literally go everything to the right and everything to the left. So again, the entire number line will work. Every number on there, 1 will work, 2 will work, 3 will work, 1.5 will work. Every single number on that number line will work. That's why it's all solutions. So let's look at this scenario. So if I start solving this at -4x from both sides, it looks like the exact same problem. Hey, the x is crossed out, but I want you to notice I have -5 less than -6. And so you have to ask yourself, is this a true statement? Is -5 less than -6? Well, remember what I said the other day, if this was 0 and -6 is here, -5, remember the farther to the left it is, the less it is. The farther to the right it is, the greater it is. So this statement right here, -5 is less than -6, that's not true. Because -5 is farther to the right, which means -5 is greater. So this is actually a false statement. Okay, but again, that's not the answer. The answer, remember, is I'm trying to find out what x is. What numbers work for this? Well, there are no x's that will work. So literally, if you took 4x minus 5 is less than 4x minus 6 and plugged in any random number to your x's, plug them into your x's, it won't work. It will end up being a false statement. I mean, try 2, try -2, try 500, try 0. I mean, nothing will work on this. So this is actually no solutions. Okay, there is no solution or solutions for this inequality because the variables cross out and it becomes a false statement.